Good morning, class. Today we're going to be talking about Chapter 3 in the 2014 Residential Building Code. Now, if you look at the online content, you'll see that we've taken Chapter 3 and divided it into 2 weeks. The reason I'm doing that is because there's quite a bit of material here, and I feel like that covering all of it in 1 week is maybe more than I want to throw at you right at this point in time. Anyway, so Chapter 3 is broken into 2 parts. This week is going to be Part 1, and if you look in the text, if you happen to have a textbook, it'll be up through R307 or page 3-25 if you have a textbook. For those of you that are using the online PDF file from the state of Oregon for the code, the R307 is where we'll approximately cover in this week. Anyway, Chapter 3 is titled Building Planning. And for those of you students that are on the design side and plan on doing some architectural work, possibly design work, maybe small remodel, this is information that you need to know. This is going to help you understand how you can put together a set of details and plans that will then be code accepted, so that when you submit for a permit that you have all the appropriate design criteria or information part of that plan. So if you look in the very beginning of this chapter, it talks a little bit about what the actual scope of what it is that you can design to. And for the most part, here in the Building Construction Technology Department, we have basic standard construction principles that we're following, what we call platform framing or balloon framing, and basically it's the 2x4s, 2x6s, girders and trusses and headers, the standard system of building that we've had in this area for years and years. So this chapter in section R301.1.2 kind of describes that, yes, that's what we're covering. Now, if you have, say, a situation where you're doing an alternative method of building, could be SIP panels, it could be ICF blocks, I don't know, there's lots of other kinds of systems out there, straw bale, whatever it might be. Those systems are going to be outside of this regulation, so you'd have to find additional code information if you were actually seeking information on an alternative type system. But for those of you that are coming into the program, we'll probably be building standard stick frame. This is the information that you'll need to know. And then those of you that'll be designing, this is also good information because it'll help you facilitate what it is that you're actually going to be working out in any design. Now, I've found over the years when I was building and some of the projects that I've been working on, that the smaller the structure, the harder it is actually to design, to make sure that you meet all the components that the code is requiring: room sizes, ventilation, egress, all of the kinds of things that are entailed in a design. And actually, as you get larger, because you have more area, I actually found it was easier to design. So take that into consideration. Anytime we're working with a structure, you'll find that there's different components to the structure that you need to be aware of what those areas entail and what the design or engineering requirements are going to require. Now, with the type of construction that we're talking about, the stick framing, we have different areas that we're going to look at that help us in that design of the structure. Now, some of you are familiar with like wind loading. When you live in an area where you have conditions that are going to produce winds of 80 miles an hour, 100 miles an hour, you have to design the structure to meet that requirement. Or if you live in a seismic area, the requirement for the design is going to be specific to the design or to the requirement of that seismic loading. Excuse me. And basic structural requirements, floor joist sizes, rafter sizes, truss designations. All of these things have to meet engineering principles. And one thing nice about the code, for the most part, the code provides you all of this information in a pre-engineered format. And it's what we call the prescriptive code. And if you meet all those requirements, you're good to go ahead with your project. Now, a lot of builders and tradespeople actually will take their designs or their plans to an engineer and have them specify some of these criteria. But I found in the past when I was building that if we could meet the prescriptive requirement, it saved us time and money. And so I tried to always try and do that. So as you go through the first part of this chapter 3, you're going to learn about different requirements that are going to be specified as you consider the design of a structure. Now, the information that we're pulling from this chapter is going to be pertinent if you're actually doing a design, but it also applies to a plan. Let's say you ordered a plan off the internet, found a plan book, and ordered a set of plans from somewhere. You can still apply this information to that plan. And so whether you're actually designing or using an existing plan, you want to be aware of the conditions that need to be met so that you're in code compliance. One of the first things that I want to talk about is just a little bit about some of these requirements that I've been discussing here previously. In the code, as you come into it, first page, we talked about some of the requirements as far as meeting stick framing type design. But the very next page is a table, R301.2 parentheses 1, and in this table it gives you a great deal of information. And then the next several pages are going to have additional tables, charts that have information that's pertinent to any design. Now, when we discussed about the code here in Oregon as being an adoption from the IRC, or the International Residential Code, the state of Oregon has gone to great lengths to provide additional information that is pertinent just to our state. And so here on the very next page, on the first part of the chapter, you have a table here that gives you a breakdown of specific information that you'll need to know depending on where you live, the type of work you're doing, and the conditions that will be in that area. So this chart breaks down the state by county, and these counties then have specific information. So like on the coast, you're going to have wind loading. Down the gorge, you're going to have wind loading. Different parts of the state are going to have seismic requirements. Some parts of the state are going to have snow load requirements. It just depends on where you're located. And so depending on what it is that you're working on, you want to be aware that this information is out there. Now, also, along with this information, you have weathering requirements. Now, different parts of the state, depending on the weather, is going to affect how your structure is going to handle that. And so concrete building components are going to be weather beaten depending on how much weather exposure they face. And so then you need to know what the requirements are for that area. Years ago when I was building, we had a kind of rule of thumb for different kinds of things, especially when we were building like floor and roof systems. And one of the things that you're going to find in the first part of this chapter is that you need to understand a little bit about loading. Anytime you build a structure, the objective of the structure is to take the component of the materials and also any additional loads that might be applied and transfer those loads from the structure through the walls, through the floors, into the foundation, from the foundation into the ground. And so years ago we knew that anytime we were building a structure we had to meet certain loading requirements, and in the code you're going to find that different areas require different load bearing capabilities. For floors, one of the things that we used to follow as a rule of thumb was that typically you would have a certain load bearing requirement for just the materials of the structure. So let's say you're building a house and you have so much square footage, and the design requirement would be that, let's say, for every square foot of just building materials it would have to be designed to meet a 10-pound load per square foot, and that's just the building materials. And then on top of that we used to use another factor, let's just say 40 pounds per square foot, for what we would call live loads. And these live loads will reflect people coming in and out, furniture, whatever it might be, beds, anything that you could possibly bring in and out of the structure potentially is considered what we call a live load. And then we would combine that 40 pounds with the 10 pounds to get a total of 50 pounds per square foot, and then that would be your design requirement as you figured out, say, a joist layout system. Whether it's going to be 2x10s or 2x12s and what the spacing will be. Now later in the book we will take a look at floor systems and joist layout and design and load bearing capabilities. So anyway, back here in chapter 3 you just need to understand that these requirements are out there based on what this chapter is going to define, that's going to help you in your perspective as you're working and designing or figuring out what the requirements are for an existing plan. Also in this section you're going to learn a little bit about glazing, windows, requirements for windows, a little bit about separation, fire separation, say for your garage, some information that's pertinent to that. Mechanical ventilation, like bathrooms require certain fan requirements, ventilation, circulation, and some different components to what will be required in this first part of the chapter. At this point, students, I don't see anything else on my notes that I'd like to cover. Let me just take a quick look here at the book real quick. As you get into the chapter, you're going to find not only the tables that you see in the very beginning of the chapter, but you're going to find some other charts and tables that are going to give pertinent information. So as with any chapter that we're going through, make sure you read through. The first half here would be from page 320, or from the beginning of the chapter to page 325, or to section R307. Good luck with this reading assignment this week, students. As you do the assignment, if you have any questions, be sure to let me know, and we'll talk to you again next week. Have a good week. Thank you.